so much for being here. I'm really excited to be teaching this workshop. This is the first time that we're offering this workshop with Stats Horizon. I teach other workshops for Stats Horizon, but a lot of the time when I'm doing that, I am mostly talking about work that was developed by my graduate advisor, Dr. Andrew Hayes. So this workshop is really exciting because it is really kind of my bread and butter, which is these repeated measures designs. So what we're going to be doing over the next 2 days is talking about both mediation and moderation, and I'm hoping a little bit of moderated mediation. So I want to talk briefly through what it is that we'll be doing each day so that you can get a general sense of our plan. So day one, we're going to focus primarily on mediation and moderation, or mediation, and we're going to do kind of a general introduction to the distinction between within and between subjects designs, as well as an overview of mediation in a between subjects context. I kind of assume that most people learn about mediation for the first time in this between subjects context, but if it's the first time for you, we are going to start from the absolute basics. So what I'm doing in the between subjects review is really to maybe connect to some of those neurons that have maybe not necessarily pinged in a while and get some of these ideas percolating. But if they're brand new for you, that's totally fine. If you're interested in going into the nitty-gritty of the between subject stuff, that is mostly what I teach in my other Stats Horizon workshop, which I think is just called Mediation, Moderation, and Conditional Process Analysis. And then the core of what we're going to be doing today is within subjects mediation analysis. So we'll talk about estimation, how do we actually get coefficient estimates, and how do we make inference about them. I will introduce the MEMORE macro, which is a really nice tool for SPSS and SAS that does a lot of this estimation and inference for us. So it just kind of automates a lot of the process. We'll talk a lot about causality. This is a really core aspect of mediation. The mediation is an inherently causal model, and so we cannot ignore that necessarily. But there is often not a lot that statistical analyses have to say about causality. So we're going to talk about that separately. And then I also want to give you a bunch of tools for actually doing these kinds of analyses in your own research, whether that's in a paper or a dissertation or a thesis, whatever it is that you're producing. We'll talk about how to do power analysis, things like pre-registration, what kinds of things you might pre-register, or how do you write about these things, the different kind of visualizations that you might create for publication. And then in the end, I'm hoping we have time to talk about multiple mediator models. So what if you want to have multiple mediators in a model together? And then just to wrap up today, I'll talk about extensions of this simple model that we're working on and where to go to learn more about those extensions. So for example, multi-level models or latent growth curve models integrated with mediation analysis. So that's our goal for today. Tomorrow, we will focus more on moderation analysis. So we'll start with a just general review of moderation analysis in between subject designs. And then we'll focus on the within subject design. So things like estimation and inference, visualizations, probing interactions, again, using the MEMORE macro to get a lot of this stuff automated, and then power analysis and pre-registration. And then I'm hoping we'll have some time at the end of the day tomorrow to talk about integrating mediation and moderation together. And this is some very, very new functionality that's available in MEMORE. So we'll talk a little bit about the kind of different steps that you can take in using MEMORE to estimate these models that integrate mediation and moderation together. And then at the end, we'll just wrap up with some, recommendations for where to learn more, and kind of ideas for the future. There are a number of other Statistical Horizons workshops that teach extensions of these methods. So hopefully you'll have a nice pathway for where to go from here. So to talk a little bit about the procedures for what we'll do, just a reminder, this is where you can download the GitHub file. So go to this GitHub, find the little green code button, click the down arrow, and then download the zip. I'm assuming that you are generally familiar with linear regression. And then I assume that you have some familiarity with mediation and moderation in between subjects designs. But again, as I mentioned, if this is the first time that you are learning about mediation and moderation, we are going to build this up completely from the ground up. So hopefully, even if you don't have experience with between subjects designs, it may be that the between subject sections feel very quick because that's not something that you're familiar with, but within subject stuff we'll go through in great detail. And then I assume that you are using SPSS or SAS. I had a couple people message me and ask about R, so but the memory macro is not available in R. So what I've done is I've integrated R code on the slides where there is available R code, but there's not R code for everything. So I assume that everyone has access to SPSS or SAS for what it is that we're doing today and tomorrow. And just schedule wise, essentially what we do is kind of a 2-hour block in the morning for, I don't know, I guess anybody in the continental US or Canada or South America. So 10:30 to 12:30 Eastern. I'm on West Coast time, so we started at 7:30 for me. And then we have a 30-minute kind of lunch break. I will introduce an activity for the lunch break. So if you want to use those 30 minutes to kind of solidify some of the understanding that we've been developing, there's something that you can do there. And then we'll come back for another 2 hours in the afternoon, or maybe for you evening or morning. I don't know, but we have a lot of people who are all over the world, which is really exciting. So essentially 2-hour block, 30-minute break, 2-hour block. And just to talk a little bit about how we learn in this course. So I'm going to talk about a combination of theory and practice. I pretty much always have a data set that demonstrates the ideas that we are going to be learning. My background is in psychology, so a lot of these data sets come from psychology examples, but we will essentially kind of walk through some of the mathematics, some of the theory, and then immediately put that into practice with a real data set so that you can see how those equations or ideas really translate into the way that we analyze real data. You can follow along with the analysis as we go. I know that this is sometimes a limitation just depending on your computer setup because you have, the Zoom window and you have probably the slides up, and maybe it's just too much to have also SPSS or SAS open. So one thing that you can do is like use the break or the time in between the days to review and go through and actually do the analyses that we do in the course, because it's going to be important for you to practice as we go, just to make sure that you understand how to actually do the analyses. For you SPSS users, I'm going to push you to use syntax. So I'm only going to provide syntax. I'm not going to provide point and click instructions for a combination of reasons. Syntax is much more reproducible, so it's creating a document that actually documents what it is that you did. And it's a lot easier to put on slides rather than this kind of constant mini windows point and click. Super. So just to overview what it is that you will need, we will use SPSS, SAS, and then sometimes you can use R, but we can't use R for the whole workshop. But if you are would really prefer to use R for parts of it, you can. So on the slides, the way that I have this organized is there is SPSS code in a black box with white text, SAS code in a white box with black text, and R code in a gray box with black text. So hopefully you can always kind of figure out which text you need. And then on the GitHub, there are a number of files. So probably most importantly, there is a folder with data, and there's a folder for SPSS, SAS, and R data. And these are the data sets that we'll use for this course. So you need access to those. The SPSS files are saved in a way that if you just click on them, they should open as a data file. For SAS, they are a program. So they actually read in as more of like a syntax file. And then you have to run them for the data set to be saved into your work environment. And then for R, I just have CSVs. The macro files have a number of different macros in there. So I've given you access to actually 2 different versions of memory, which we'll talk about shortly. And then also ML-Med, which is a multi-level mediation macro, which if we have some time to talk about today, I will also talk about. And then there's a miscellaneous folder that just has kind of papers that come up frequently with questions that people have. Oftentimes what happens is as people are asking questions throughout a workshop, I will mention a specific paper and then add that to the miscellaneous file. So that folder typically grows throughout the workshop, and I will update those either during the break or at the end of our day so that the files are available to you. So you don't have to go hunting down PDFs of papers by so-and-so. Yeah, I think, oh, the last thing that I want to mention is this is a lot of material for 2 days. It's, 8 hours of learning. So it may require a lot of stamina. One thing that I think is great about the way Statistical Horizons does this is all of these sessions are being recorded, and you will have access to the recordings for a period of time after the workshop is over. So, if you get to a point today where you're just like, I gotta tap out, that's okay. You're welcome to come and go as you need. If you have meetings or something you need to pop in and out, not a problem. You are welcome to kind of come and go. If you're sitting here for the whole time, just be patient with yourself. It's a lot to learn in a very short period of time. So I think these short form workshops are really wonderful for getting a lot of information really quick, but also our brains are not really used to doing that most of the time. So be patient with yourself and take care of your body and move around as you need to. One short thing that I'll mention for our R users, there's a couple R packages that I use just kind of in the background for the code that I give. I try to keep the number of packages that I use pretty minimal, but these are some of my favorites, so I just can't live without them. So Mosaic, ggFormula, which is kind of a easier version of ggplot, JTools, and dplyr. So if you are trying to run code that I've given you and you don't have the right the packages loaded, it's probably one of these 4 packages. And then typically I just use like the read CSV function to read in data, but you can use whatever functions that you prefer. And if you know of another way to do the same thing that we're doing, oftentimes, especially in R, there's like 80 bazillion different ways to do the same thing. Okay. Great. So I want to talk briefly about study design. because this is such a core aspect of what it is that we're doing in this class. So I'm going to differentiate between what I will call between subject designs and within subject designs. There are a lot of different names used for a lot of these things, so I want to kind of introduce the way that I think about them. And I will note that I often use repeated measures and within subjects kind of interchangeably. We'll talk about that a little bit. So this course in particular is going to focus on within subject designs, but in contrast to between subject designs, we'll kind of talk about both. Whether we're doing a mediation or a moderation analysis, so regardless of the kind of analysis, we're always going to have a focal predictor, which I'm going to call X, and an outcome that I'm going to call Y. And we're going to use this focal predictor and outcome to define our between and within subject design. So one thing that I want to point out is that the way that we talk about the design actually does depend on the variables that are the focus of our analysis. So there are study designs where I might say, oh, well, if you're doing this analysis, it's a between subjects design, but if you're doing this other analysis, it's a within subjects design. So it does depend on your choice of the focal predictor and the outcome. So to determine the type of design, we're only going to focus on X and Y. And then as we get into thinking about mediation and moderation, we'll integrate this into our framework. So in a between subjects design, our focal predictor X is observed only once per subject. So it could be randomly assigned, such as like a randomized control trial where we are randomly assigning each participant to one of some number of conditions. Or it could be something that is observed. So when I say between subjects design, I don't necessarily mean an experiment. If I do mean experiment, I might say something like between subjects experiment, which would imply that X is randomly assigned, but X could also be observed. So for example, handedness, whether somebody is left or right-handed. The outcome is also observed only once per subject. So we could look at things like typing speed or some other variable where we're only testing people once. So as just some examples of between subjects designs, we could look at an example like this, where we say human participants are randomly assigned to complete a math test in either a hot or cold room, where the temperature of the room is our X variable, our focal predictor, and their performance on the math test is then measured. So I want you to, in the chat, just share whether you think this X here is assigned or observed. So just as a reminder, we can have X, which is randomly assigned, where the experimenter is deciding the level of X, versus when it's observed, we're finding people and they just have a level of X that we can decide. So why don't we share in the chat for this example, whether you think it is assigned or observed. Great, it looks like there's lots of agreement. This is assigned, right? So the example specifically says the participants are randomly assigned to either a hot or cold room. We could think of another example where researchers want to compare startups in finance to those that are in health. So X here is going to be the type of company, either finance or health. And they are going to compare them on their number of employees in the first 2 years, which is kind of an interesting statistic to look at for startups. So for this example, let's look at whether you think this is assigned or observed. So you can share in the chat. Great. So lots of people are saying observed. Yes, so we have not in any way randomly assigned a company to focus on finance versus health. We're just finding companies and then observing whether they are a finance company or a health company. So that has not been randomly assigned. So here our X variable is observed. So in this course, I'm typically going to focus on X variables that are categorical, but they can also be continuous. So for example, if we circled back to our hot or cold example here, if you were the experimenter, there's a couple ways that you could think about doing this. One would be, okay, I have, complete control over this room. I'm going to set the heat in advance to either like a specific very hot temperature. Let's say I'm going to set the room to be, I don't know, 84 degrees Fahrenheit versus like 60 degrees Fahrenheit. And I believe that everybody who's in the hot condition is in the same temperature and everybody who's in the cold condition is in the same temperature. So I'm just going to have levels of hot and cold. Or sometimes we might also want to just double check that we've done that correctly. So put a thermometer in the room to measure the temperature, and then we would have numeric information. And one thing that we might see there is that for people in the hot condition, maybe some of them were at 85, some of them are at 84, some of them are at 86. And in the cold condition, some of them might also vary a little bit in temperature. So even though we tried to assign the levels of X, we were really only successful at assigning kind of hot or cold, but then we could also measure or observe the actual temperature. And there was a comment in the chat that said it could be either or both, essentially. And I think this is one way to think about how, depending on the way that the variable is represented in the data, this can affect whether we think of something as an experiment versus, cross-sectional or observational data, and also similarly like within or between designs. Okay, so this is probably like review of introductory level research methods. I actually pulled some of these from when I teach research methods because I think that they're fun. So let's talk about within subjects designs, which is the focus of this course. So in this case, X is going to be observed or assigned multiple times per subject. So in this case, we are going to observe each subject multiple times under different values of our focal predictor. And again, this is a really important aspect of why we need to define what our X is in order to say whether or not it is a within or between subjects design. So when X is assigned, we could think about this having a study with multiple conditions, and participants participate in both conditions, kind of responding to questions or providing information in each of the conditions. So we're going to focus on cases where every subject is observed under the same values of X. And that will be when we have assigned X values. We can also have observed X values. So for example, we could measure people on some variable across time, and that would be observing them repeatedly. But the values of X may differ across different participants. For our outcome, we need to observe the outcome under each instance of X. So again, this is an important aspect of why our focal predictor and outcome need to be defined in order to determine the type of design that is used, because we need to have a measure of y for each level of x in order for it to really be within subject's design. And typically y is only observed because we're thinking of it as an outcome. So just to give a couple examples of within subjects designs, and I've tried to make some of these similar to the previous ones so that you can kind of see the connection. We could have human participants complete a math test both in a hot and a cold room. So they're going to do two different math tests. Hopefully they are similarly difficult math tests. And one they're going to do in a hot room and one they're going to do in a cold room. And then their performance on the math test is measured in each of those two temperature conditions. So in this case, in this example, would we consider X to be assigned or observed? So just as a reminder, in our within subjects designs, we can have conditions that are assigned by the experimenter, and then every subject has the same values of X. Whereas if X is observed, then different participants may have different values of X. So for our first example, this is kind of a repeat math test example. Let's share in the chat whether we think this is observed or assigned. Okay, I see a lot of assigned, a couple observed. So for the most part, we would consider this assigned. But then again, if we were measuring the actual temperature within the room, and there might be some variability there, then we could also think about this as somewhat observed. Rebecca asked a great question in the chat, which is, what about counterbalancing of the order? Should we include this as a control variable? So yes, so this course is not necessarily a experimental design course, but if you took an experimental design course and learned about within subjects designs, and an example like this, like taking a test in a hot room and then a cold room, one of the things that is often recommended is to counterbalance the order that people do the conditions in. So for example, you might want half of those people to be in the hot room first and then the cold room, and half of those people to do the cold room first and then the hot room. The question then, though, is what do you do with that information? And in this class, actually, we're going to look at order as a moderator to see if the effect of temperature, for example, that's not the actual data that we have, but to see if the effect of temperature on performance differs between those who take the hot test first versus the cold test first. So in other types of analyses, you might include order as a control variable. In this course, we're going to look at it as a potential moderator of our treatment effect to see whether the effect of temperature on performance varies across different levels of order. It's an interesting thing, though, because then if we were interested in the effect of order, that is actually something that is between subjects and randomly assigned. So if we were thinking about the order that people did this in as our X variable, then we would consider that a between subjects design and approach the analysis differently. So I think that this is a good example, again, of how what variable is your X variable is going to determine whether you think of the design as a within subjects design versus a between subjects design. Super. Let's do another example. So we're going to look at number of employees is measured at the end of the first year and the second year of across many different startups. So here, X is going to be the age of the startup. So we're going to observe startups for 2 years, and we're going to observe them in these different cases. So we're always going to be observing the startups at the end of their first year and at the end of their second year. So in this case, would we consider X to be assigned or observed? Okay, we've got some mixed feelings on this one, which I think is fun. So this example is I think a really important one because it points out some of the differences between the way that we think about between subjects designs and within subjects designs. So again, when we talk about the distinction here, the core aspect is that when X is assigned, every subject is observed under the same values of X. Whereas when X is observed, then the values of X may vary across participants. So if there's something in the design that forces the values of X to be the same across all of the participants, in this case, companies, then it is assigned. It's not randomly assigned. So this is something I think that is kind of interesting about the distinction between and within subjects designs is we're used to always saying randomly assigned. And we know, I think a lot of the times, especially in the social behavioral sciences, we really know what randomly assigned means. But what does it mean for something to be assigned? I can assign when I survey you. And that's the case in this example, is that we have assigned when we collect data from these specific companies. So all of the companies, their age of startup is going to be the first year and the second year, and they're going to be at the exact same point for every startup. So in this case, it is assigned. It is not randomly assigned. Whereas if we just like surveyed some startups, maybe they might vary in how old they are. And in that case, it would be observed. So for example, if I looked at the number of employees at a startup measured 1 year apart for each startup, but I don't account for how old each of the different startups are, in this case, this would be observed. So this is kind of like two of the same studies, but they have different properties because of the way that they're designed, where in this kind of second example on the slide, every startup is surveyed at year 1 and year 2. Whereas if we look at the number of employees measured 1 year apart for just a number of startups, then we might have some startups that are surveyed at year 3 and year 4, some startups that are surveyed at year 1 and year 2, year 5 and year 6. So we can't account for or we're observing the age of the startup. So there's a question in the chat. We cannot assign age, but we can observe age, but we can assign the ages that we observe, if that makes sense. So I can't randomly assign you to be a specific age, but I can design my sample in a way where everybody is the same age, which is essentially assigning age. So I think part of this is that the language of assigned and observed is often used in the case of between subjects designs, and it has been kind of like ported over into within subjects designs, but has slightly different meaning, which is one of the reasons why I wanted to point this out early in the workshop, because it is very important for the way that we move on. Super cool. So you can see how some of this is a little bit more ambiguous in within subjects designs. And I think it's not as common for us to think about designing studies in this way, but it will be important for the way that we conduct our analyses. So the next thing I want to talk about is the distinction between repeated measures and within subjects designs. So repeated measures is a really broad term that is used in a lot of different contexts. You'll notice the workshop itself is kind of advertised as within subjects, which is a subset of repeated measures. So you might hear me use both terms, and both terms are correct in this case because we are focused on within subjects designs. But we'll talk a little bit about some of the differences. So there are a lot of different kinds of repeated measures design. So we could survey people across time. We could have nested or multi-level data. For example, individuals within schools can be considered a repeated measures design because we are measuring different people within a school. So we're measuring the school repeatedly. We could think about things like dyadic data, so twins or couples or lab mates or roommates. And we could measure people under a variety of different circumstances. All of these kind of fit under repeated measures designs, but we are going to kind of narrowly focus on the within subjects designs aspect. So in general, when you're thinking about repeated measures designs, it's very important to think about how, when, and how many. Those are like often the first 3 questions that I ask when somebody emails me and they say, oh, I have a repeated measures mediation that I want to do. And so it's important to think about how the repeated measurements are generated, when are they measured, and how many times they are measured for each of the variables in the mediation model. So in a within subjects design, X is assigned and Y is observed, and that happens repeatedly. So there's multiple observations. Multi-level mediation has a really nice system referring to kind of levels of the observations. So so in a mediation model, there's an X, an M, and a Y, and they have this kind of 3-number system to refer to different types of mediation models. Something else that you want to think about is whether the focal predictor is measured repeatedly. So if the focal predictor is not measured repeatedly, then it's not a repeated measures design for that specific analysis. That's, again, we talked a little bit about like order, right? So you can only experience the manipulation in one order. So if you're focused on the effect of order, then it wouldn't necessarily be a within subjects design for that analysis. And then one of the core aspects of what it is that we'll be talking about in this workshop is that the focal predictor is what differentiates your repeated measurements. So like the hot and the cold room, the thing that we are very focused on is the temperature of the room as some kind of causal force. And if I had, let's say, I had you in a hot room, but you were in a hot room 3 times, then what differentiates the repeated measurements isn't the focal predictor. So that is something else that is important to think about as you're kind of classifying different designs into different buckets. So this course is very focused on a specific within subjects design, or it's sometimes called a 2-instance repeated measures design, where the focal predictor is the factor that differs the repeated measurements. So X is assigned twice in our case. We'll talk about cases where you have more than 2 observations and what to do then, but we're going to focus on just 2 to start out. And then for mediation analysis, X is measured in each of those 2 instances, and Y is measured in each of those 2 instances. So even though I'm saying that X is assigned, again, remember, think back to the company example where you're measuring people at the 1st and 2nd year. That is technically also a way to assign age of the company. You're assigning when you measure them. So even though I'm not randomly assigning, then we are thinking about this as being assigned because every case has the same levels of X. Question. So I thought when you said repeated, time is repeatedly measured, schools and dyads are also repeatedly measures without considering time. Yes, so you could measure schools and dyads across time, which is like doubly repeated. But so when we think about dyadic data, if we think about a twin as something that we measure, we might or a set of twins as something that we might measure. If we ask each twin a question, then we are measuring that twin set repeatedly. Or a couple, you might ask each of the partners in a couple. And so that is considered repeated measurements because those two measures are reflective of the couple. Even if they're not measured over time. You could then also measure twins or couples or schools or something over time as well. Yeah, so Rebecca had a question. Can we apply this to pre-post designs, measured Y twice for the same person? Yes. So this would be when we're measuring each person over time, and for a 2-instance repeated measures design, as long as everybody is measured at the same 2 times, and the way you define time can be used to your advantage. So for example, if everybody is going through the same treatment, or I've done this with classes where we measure everyone at the beginning of a class and then they all go through the same class, and then they are measured again at the end of the class, then that is a 2-instance repeated measures design. If we add in, for example, like random assignment to some condition, it depends on whether our focal predictor is our time variable, the pre-post, versus the random assignment, which is then between subjects. And we'll talk about that a little bit in this workshop as well. Super. So just to give a couple examples of these kinds of designs. So we might have participants read 2 scenarios, and we're interested in how some aspect of those scenarios influences our outcome Y through M. So we're going to measure the mediator and the outcome in each of the different scenarios. So one thing that you might notice is that when we talked about the designs, generally, I only talked about X and Y. And one of the reasons for that is that for mediators, they essentially follow all of the same properties that the outcome does. So I had a consulting meeting recently where somebody didn't measure their mediator in each of the different, for like this example, scenarios. So you can't really see how the scenario affects the mediator if it's not measured in each of those scenarios. That might be like measuring your mediator at the beginning of your treatment and not at the end, right? Or only at the end, because then you can't see how it changes. So just like Rebecca mentioned, pre-post tests. So a therapist could measure symptoms and outcomes before administering some kind of intervention, and then after administering that intervention. And then I wanted to give an example of how we can think about dyadic data as a way of in this 2-instance repeated measures design framework. So we could think about researchers interested in if the male partner in a heterosexual relationship believes fights are less severe because they are less perceptive of these kind of small altercations. So you could measure both male and female partners in those relationships, and they could self-report the number of squabbles and severities of the last fight. So an important aspect here is that the couples themselves have 2 members, and the question is about the gender of the member of the couple. So in that case, in all of these couples, if they're all heterosexual couples, then we would have 1 male partner and 1 female partner, 1 partner who's a man and 1 partner who's a woman. And then our X variable, the focal predictor, is assigned, even though I haven't randomly assigned anybody their gender, but I have selected couples where we have 1 of each kind of type. And so this fits into this 2-instance repeated measures framework. So hopefully you can see, even though it feels kind of restrictive, there are actually a lot of kinds of designs that fit within this definition. My easiest explanation when people are like, what specific design do you work with? I always say, like, it's a paired t-test. Whatever you learned, you can apply paired t-test to, like, this is it. This is mediation for the paired t-test designs, except To me, a paired t-test is a type of analysis, whereas designs are more general. But the kind of designs that come to mind when you think about paired t-tests, that's the kind of designs that we're thinking about. Super. Terrence, you have raised your hand.
Sure. So just to be clear, the pre-post test, your second bullet, you say X is assigned twice. It seems to me like the outcome is measuring the symptoms and outcomes before and after. So I see those two instances. What would be the X that measured in those two instances?
Yeah, so we could think about it one of two ways. One would be just time, right? So we could say, okay, we could call it pre-treatment and post-treatment.
Okay.
Or we could think about it as the presence and absence of the treatment. So you could say, like, these people have no treatment because they haven't received the treatment yet, and these people have received the treatment. When we have more complex designs where we track people across time, then, and we'll talk about this a little bit throughout the workshop, but the specific design we're focused on would just have like 2 time points. Yeah.
And is there an M in that instance too, a mediator?
Yeah, so in this case, let's say we were interested in measuring an outcome of like depression, right? Then we might be interested in some specific mechanism that this treatment introduces. So for example, we want to maybe reduce rumination, which is when people are kind of cycling through negative thoughts repeatedly. And this specific intervention is aimed to reduce rumination, which should then reduce depression. So we would measure both rumination and depression before they've received any treatment and again after they've received the treatment.
Okay, and is there a strict temporal ordering of, I'm used to thinking of X as an exposure, M, the mediator has to come after X, and then Y, the outcome has to come after the mediator. Does that thinking apply here also?
Yes, we'll talk a lot about temporal ordering and the importance of it in mediation analysis. In this case, one of the things in particular that pre-post designs are not very good at is anything else that changes over time naturally is kind of confounding all of these effects. So if everybody goes through the same treatment, we don't know if what changed them is the treatment or something else, right? And you can imagine, what if we were studying depression with, I don't know, LGBT communities, and there were big changes in laws or policies around that time that could completely mess up our measurement of thinking like, oh, this is because of the treatment. So one way of addressing that is by randomly assigning some people to the treatment and some people not to the treatment, and then they're still measured pre and post. We would call that like a 2-condition pre-test, post-test design. And so that adds another layer of variables. And I think a lot of the time we're used to thinking of that random assignment as our X variable, but we can also think of it as a moderator of the mediation. So we can see, do the people who receive the treatment look similar in their processes to those who didn't receive the treatment? And that's something we'll talk about in this workshop as well.
Very helpful, thank you.
Absolutely. Super. So, oh, maybe I also answered Rebecca's question. How do we measure M twice in the pre-post example? Super. Yay. We're all on the same page. Awesome. Okay, I want to give a couple counterexamples just to give an idea of what types of things might not apply to what it is we're thinking. So for example, if I look at this question of, does calorie consumption impact body image through weight gain over time, where I'm just measuring people on their calorie consumption, maybe two weeks in a row, and I measure their calorie consumption, weight gain, and body image. In this case, X is going to be observed. So not everybody is consuming the exact same amount of calories. Their calorie consumption may vary from one measurement to another, but not everyone is going to have the same values. And so the analysis that we're going to talk about for this course is not going to apply, but it could be dealt with in a multi-level or latent growth approach And that's something that I will talk about kind of where to go from this workshop. But the analysis that we're doing is actually kind of a simplified version of both multi-level and latent growth curves. So getting familiar with this analysis will help you, I think, develop some intuitions for more complex designs. And then any case where the repeated measurement is like a nuisance, which is kind of a funny term, but this idea that like, if we could, we would just get independent cases. But for some reason, there's nesting in the data. So this happens a lot when we are studying educational questions, is that we just can't ignore the fact that kids are in classes together. And so kids in classes together are more similar than they are not. But the repeated measurements is kind of a nuisance or a problem rather than part of the natural design of the study. So in those cases, we would not typically use this kind of analysis, but a multi-level analysis would also be appropriate. So in this case, X is observed and it doesn't vary within the subjects of the study.